Hello guys, today we're going to begin 2.4 or the zeros of polynomial functions. Now, previously we were able to tell up to how many real zeros a polynomial has based on the leading coefficient or leading term, just based on the degree. Today, you're actually going to be able to tell what possible values they have just by looking at a polynomial and then using the graphing calculator to quickly determine what the actual zeros are if they are rationals. Now, let's go over example 1. Example 1 states, what are the zeros of a polynomial when the leading coefficient is 1? All you have to do when the leading coefficient is 1 is focus on your constants. And the zeros will be all possible positive or negative factors of that constant. So, pretty much, actually, I'm going to give you the actual rule. The actual rule says the factors or the zeros are P divided by Q, where P is all the factors of the constant and Q is all the factors of the leading term. Since the leading coefficient is 1 and everything divided by 1 is pretty much the original number, when the leading term is 1, this number right here, when you have a 1 here, all you do is focus on the constant, and either all positive or negative factors of that constant will be the possible solutions. So in this polynomial, the solution will either be positive 1 or negative 1. There will be no other rational zero expressed in this polynomial. Now you can quickly graph and easily verify if it's positive 1 or negative 1, or just plug it in and see what you end up with. And if it's not any of these, it's an irrational or imaginary zeros. You don't always have to have the zero, but if you do have zeros, it's going to be one of these two values if it's a rational zero. Let's see a different number. Again, whatever's in front doesn't really matter. All you care about is the constant. And it doesn't matter if this is x cubed or whatever. Leading coefficient is 1. The factors of 6 are 1, 2, 3, and 6. Positive or negative. So the zeros to this polynomial, if they are rational, are going to have to be either positive or negative 1, positive or negative 2, positive or negative 3, or positive or negative 6. There can be no other rational zeros. Those are going to be the zeros. You can quickly plug this into your graphing calculator and just visually confirm the zeros pretty quickly. And that's pretty straightforward. So again, if I were to tell you, let's focus on this particular polynomial, 24. Could this be a possible answer? 1, yeah, it could be a possible 0. Could negative 2 be a possible 0? Yes. Could positive 3? Yes. Could negative 5? No, because negative 5 is not a positive or negative factor of 24. The factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. If it's not one of these numbers, either positive or negative, it will never be a solution to this polynomial. So when you're looking at this rational zero theorem, it can tell you which are possible answers, but it might not tell you all the answers. Because again, if one of the answers is an irrational zero, it's not going to show up. But it can tell you which ones cannot be answers. So that's why it's pretty useful. Again, if it's a rational zero. That's example 1, when the leading coefficient is 1. Now it gets a little bit more complex because now you actually have to do a division. Let's say this number is actually 4 now, and my leading coefficient is going to be 3. Again, the exact same formula, P divided by Q. P are the factors, positive or negative, they always have to be positive or negative, of the constant, which are 1, 2, and 4, divided by the factors of the leading term. It used to be 3, it used to be 1, so it didn't matter, didn't change anything. Now it's 3, so now it does matter. It's 3 or 1. So now let's look at all possible combinations. The possible rational zeros are 1 divided by 1, 2 divided by 1, 4 divided by 1, and then 1 divided by 3, 2 divided by 3, and 4 divided by 3, both positive and negative. Now repeat, this isn't telling you what the zeros are going to be, just what the possible rational zeros might be. So you would plug these values into your equation to find those zeros, or you would graph it in the graphing calculator and then confirm. Again, pretty straightforward. Those were example 1 and example 2. And we're going to leave it there for today's class. The only thing you're going to be having, you're going to have to do is list all possible zeros and then find the actual zeros. Okay, so that's it for today. Stay tuned for the next video.